Okay, let's see some application of antiderivative. This is a problem from the book. The growth rate of the shrub is given by so let's highlight key information. So we have dH by dt, which is the rate. Rate is given. So the rate information is given, right? And we want to find the height function, and also the height after 3 years, right? So given the rate of change of height, we want to find the height function. So we're coming given derivative, we want to find function. Okay. So this is the integration process. So we're going to do integration. Given let me rewrite dH by dt. dH by dt is 2.5 t plus 5. We're going to do indefinite integral. Let me write h of t. The height function is integral 2.5 t plus 5, integrating with respect to t. So this will give 2.5 integral t dt plus integral phi dt, or you can pull this 5 outside too, right? So we will have 2.5 integral of t is t squared over 2. 5 times integral dt is t plus c, right? Indefinite integral all have this plus c, and now we want to evaluate this c by using this initial condition, 10 centimeter tall, right? So initially when the plant is planted, it is 10 centimeter tall. So we're going to plug in t equal to 0. When t equal to 0, the height is 10 centimeter tall. So if you plug in this, you'll have 10 equal to what would this be? 1.25 t squared. T is going to become 0, so this will become 0 plus 5 times 0 plus c. So c will be 10. Once we evaluate c, we have the height function explicitly. The height function is 1.25 t squared plus 5t plus 10. So this is the height function. All right. So for question A. So question B is we have to find the height after 3 years, which means we want the height now when t equal to 3. So plug in t equal to 3 in this function and you will get the height when 3 years. So h equal to 1.25 3 squared plus 5 times 3 plus 10. So this will give approximately 36.25 centimeter. Okay, so let's do one more application. Okay, so this is a vertical motion problem where an object is thrown from the cliff. Let me highlight key information. So this is initial velocity 30 meter per second, and then there is a cliff 100 meter and the object is thrown from this height. We want to find the velocity function, position function, maximum height, and the time when the stone hits the ground. So we have the cliff, and this is 100 meters, and the object is thrown up. It reaches a height and comes down and hits the ground. So we want to find the velocity function, position function, maximum height. So we want to find this height. What is this height? And also for the fourth question, we want to find when the stone hits the ground. What is the time when the stone hits the ground? Right. So we're going to start off with the acceleration. Acceleration is given. It is actually given in the problem. I forgot to type. Acceleration is negative 9.8 meter per second squared. Right. So velocity is the integral of acceleration. So we're going to first find the velocity function. Velocity is integral a dt. because of this, there is a position function. S is the position function, and velocity is the rate of change of position, and acceleration is the rate of change of velocity. Using these derivatives, we're going to write the integral statements. Velocity is integral of a dt, which is integral negative 9.8 dt. So the velocity will be equal to negative 9.8 t plus c. So we want to find c. So we have an initial velocity of 30 meters per second. So when t equal to 0, velocity is 30 meters per second. So if you plug this into the velocity function, we will get c equal to 30. So rewriting velocity function, negative 9.8 t plus 30. Right? So now from velocity, we're going to find the position function, which is also the height function here. S equal to integral negative 9.8 t plus 30, integrating with respect to t. So this will give, pulling this 9.8 constant outside, integral of t is t squared over 2, plus integrating 30 will give 30t. Of course, there is a c. We're going to evaluate the c using the initial height. There is an initial height of 100 meters because the object is thrown from the height of 100 meters. So plug in when t equal to 0. The height is 100. So if you plug this into this equation above, we have 100 equal to 0 plus c. So this will give c equal to 100. So rewriting the height function as equal to negative, I will simplify this part, 4.9. So negative 4.9 t squared plus 30t plus 100. So we have the position function and we have the velocity function. Right. So this was question A. Question B. So move on to question C. Question C is find the maximum height the object reaches. So basically we want to find this height. This height, the maximum height is reached, when derivative is 0. It's a maximum height function, so the derivative is 0, or you could work with the velocity. A derivative of s is the velocity, so velocity is 0. So we could find, use one of these equations. So let's put velocity equal to 0, and we get, so we have this velocity function 0 equal to negative 9.8 t plus 30, and this will give t equal to, solving for t here, t equal to negative 30 by negative 9.8, which is 3.1. So the object reaches the maximum height at 3.1 seconds. But the question is, what is the maximum height? So we're going to find the maximum height. Once we have the time, when time is 3.1 seconds, that is the time point when the object reaches the maximum height. What is the height of the object? So we're going to use the s function. So we're going to use this s function and plug in 3.1 into the s function. So s equal to negative 4.9 3.1 squared plus 30 times 3.1 plus 100, and we will get approximately 146 meters. Okay. So let's go over this. Maximum height is reached when the derivative is 0 or velocity is 0, and then from which we get the time point when the maximum height is reached, and using the time point you find the maximum height reached. So s is the height function, right? So we'll move on to the question D. Question D is when will the object hit ground? What is the time when object hits ground? So object hits ground is what is the time point when s equal to 0. S is the height of the object, and when is s equal to 0? So we're going to use the s function. S function is from B, we have the s function. So I'm going to put s equal to 0 and find t, 4.9 t squared plus 30 t plus 100. So this is a quadratic equation. So using quadratic formula, we will get t equal to 8.5 seconds. Okay, let's continue doing antiderivative, which is also 5.1. Let's do integral fourth root of x cubed plus 1 dx. These problems are direct application of directly applying formula. Now we can use the power rule. Integral x power n dx is x power n plus 1 over n plus 1. So we want to rewrite this given problem as the power of x. So integral x to the 3 by 4 plus 1 dx. This will become right, so ready to integrate. So this is going to become x to the 3 by 4 plus 1 divided by 3 by 4 plus 1 will become 7 by 4 plus integrating the second term 1 will become x and then plus c. Right? We're simplifying this a little bit. The 7 by 4 in the denominator will become 4 by 7 x to the 7 by 4 plus x plus c. Right? So that becomes the indefinite integral. All right, let's do one more problem, maybe with the trig. Okay, so integral theta squared plus secant squared. Note that in this problem theta is the independent variable and we're going to integrate with respect to theta. Theta has taken the place of x here. So this is like similar to like integral x squared plus secant squared x dx. Right? So if you want, you rewrite an x or deal with theta. Okay. So we're going to integrate theta squared. This is the first term. I'm doing elaborately by splitting the integration. You could skip this step, d theta. So integrating the first term and then I'm going to integrate the second term. Integral of the first term is going to be theta cubed by 3. It's the application of power rule. And then integral of secant squared is going to be tangent tan theta. Of course, there is a plus c. So let's do one differential equation. Find f of x given f double prime is x squared, and also initial value condition f prime of 0 is 8 and f of 0 is 4. So from the second derivative we have to go to the first derivative, and from first derivative we have to go to f of x. So final answer is finding f of x. So first f double prime is given, so f single prime. First derivative f prime is the integral of f double prime dx. Integrating the second derivative will give the first derivative. So integral of x squared dx, this is going to be x cubed plus c over 3. So first derivative is x cubed 3 plus c, but we have to find c. We're going to use this initial condition when x equal to 0. So we will plug in x equal to 0, f prime equal to 8 using this condition. Right. So when you plug that in, 8 equal to 0 plus c, this will give c equal to 8. So we have f prime equal to x cubed by 3 plus 8. Next step, we're going to find the f of x. F of x is the integral of the first derivative